The diagram shows a section of a football pitch with H-shaped goalposts. A ball at P is 35 meters from the nearer goalpost. Calculate its distance from the further goalpost to the nearest meter. Well, straight away we can calculate this angle here. So all of this here is the horizontal ground, it's just a ground. These two angles add up to 180 degrees. So we have 180 minus 52.4. 127.6. So we want the distance of P to S, the distance of the ball to the further goalpost. So you can see in this triangle here that we have two sides and the angle in between the two sides, and we want to find this side here. So if we're looking for a side, we'll call it small a. Now from previous videos we know we have to use the cosine rule here. If we have two sides and the angle in between and we want to find a third side, we don't have enough information to use the sine rule because we're missing both of these angles. So we call this side small a, and the angle opposite small a is capital A, and small b and small c are the other two sides. And I'll call this one small b, although it doesn't matter. And if I call this one b, I have to call this one c. So the cosine rule says that a squared equals b squared plus c squared minus 2bc cos of a. So again, I only use this version of the cosine rule. Right, so a squared is 35 squared plus 5.6 squared minus 2 times 35 times 5.6 times the cos of 127.6. Now this number is a squared. We want a, which is the square root of this number. So if I put this number to the power of a half, I'll get the square root of it. So I'll write this down to 2 decimal places. So this is 38.67 meters. Notice that this side is the longest side of the triangle, and that's not surprising because it's opposite the largest angle. The largest angle in this triangle is an obtuse angle. The other two angles have to be smaller because the three of them add up to 180. So anyway, you'd expect to get an answer that's the longest of the three sides. In the next question we want to find angle TPS. So TP is one arm and PS is the other arm. So here's angle TPS. Now we can use the sine rule to answer this. We're looking for an angle, so we use the letter A to represent what we're looking for. It's an angle, so we call it capital A. Now if this is capital A, then the side opposite capital A is small a. So this is small a over here. Rename this small a. We also need a side and an angle that's opposite that side. Well, we have to use this side here. We can't use this side because if this is small b, then this is capital B, and we don't have capital B. We don't have this angle. So I call this small b, then this angle here becomes capital B. So we know that the sine rule says that A over sine A equals B over sine B, and we're looking for an angle, so we turn both sides upside down because we're going to solve this for sine of A. Multiply both sides by A, and that's how we get at sine of A. Now I've covered this a few times before, so I'll just plug the values into the calculator. So we want the sine of 127.6, and we want to multiply that by small a, which is 5.6. So this is the numerator of this is a sine b, and we want to divide it by small b, which is 38.76. So this here is sine of A. Now we want angle A, so we have to get the inverse sine of this quantity. And there it is. I'll write this down to 2 decimal places. It is 6.57 degrees. The diagram on the right represents the gable of a house. Calculate its area correct to 2 decimal places. Now we see that this gable consists of a rectangle and a triangle. The area of the rectangle is easy to get. We just multiply the sides together. So we 5.5 multiplied by 8. So it's 44 meters squared. Now what about the area of this triangle? Well, we know that the base of this triangle has the same length as the base of this rectangle. It's 8 meters. We have this formula for the area of a triangle. If we know 2 sides and the angle in between, then the area is half the product of the 2 sides by the sine of the angle in between the 2 sides. So if A and B are the 2 sides, and C will be the angle in between the 2 sides, because small c is this side here. The area is a half AB sine C. Now we could apply this formula to this triangle, but we don't have any angle. So we'd have to get an angle before we can apply this formula. So let's get this angle up here. Now it doesn't matter which angle we get because we have all the 3 sides of the triangle. So once we have any of the 3 angles, we can use this formula. We just need 2 sides and the angle in between. Any 2 sides and the angle in between. So I'll get this angle. You might know from previous videos that if we have 3 sides of a triangle and no angles, then we need to use the cosine rule to find one of the angles. We don't have enough information to use the sine rule. Now if you forget that, it doesn't matter, because if you try to use the sine rule, you'll quickly see that you can't use it, and then you'll just have to abandon it and use the cosine rule. Right, so what do we do? Well, actually I won't call that C, because I prefer to use the notation involving A for the missing angle. So I'll call it A. So if this is capital A, then the side opposite capital A is small a. And the small letters represent the sides, so call one of them small b and the other one small c. So here is the cosine rule. We want to rearrange this to get angle A. Now I've done this in previous videos, but I'll do it again. First we subtract b squared and c squared from both sides. So we get a squared minus b squared minus c squared. Then we divide across by minus 2bc. So I've done this before a few times. Now we just plug in for small a, small b and small c. So I won't bother writing this down, I'll just go straight to the calculator. I've covered this before. Right, so we want a squared. Well, a is 8, so we have 8 squared minus b squared, b is 5, minus c squared, c is 7.5. Now I'll get the answer to this, and we want to divide it by minus 2bc, so use brackets here, and inside the bracket we have minus 2 multiplied by b, which is 5, multiplied by c, which is 7.5. Close the bracket, and this is cos of a. Now we want inverse cos of this number, and there's the answer. Actually, we don't need to get angle A because, well, we could actually work with the fact that cos of A is 0.23 and use that to get sine of. We'll have to get the sine of the angle. We could do it that way. Anyway, for now I'll just note down this angle. To 2 decimal places, this is 76.70. So now we know how to get the area. We could label the sides, you know, this is small a, small b, and then we call this angle capital C. But in words, just remember that it's half the product of the 2 sides times the sine of the angle in between the 2 sides, the sine of 76.7 degrees. So we have 0.5 times 5 times 7.5 times the sine of 76.7 degrees. So we get 18.24. Well, to 2 decimal places, it's 18.25. And this is in meters squared. So again, if you want to use a notation, we call this angle capital C, and the sides are small a and small b. So the formula is a half a b sine c. So we need two sides and the angle in between the two sides, the enclosed angle. Just to go back to this, I had this incorrectly stated as 76.7 degrees. This is just 0.23, of course, and the inverse cos of 0.23 is 76.7 degrees. Now we could get the area without getting angle A. We have cos of A equals 0.23. So you can imagine a right angle triangle with angle A inside it. The cos of A is adjacent over hypotenuse. If we make the adjacent 0.23 units and make the hypotenuse 1 unit, we see the cos of A is 0.23 over 1, which is 0.23. And from this, we can get sine of A. We first have to use Pythagoras to get this side here. So that's going to be 1 squared, the hypotenuse squared minus 0.23 squared. Okay, so this value here is the square of the other side. So we have to get the square root of this number. So if I put this to the power of a half, we get 0.9732. And from this we can get the sine of A, because we need the sine of this angle to get the area. So the sine of A is opposite over hypotenuse, 0.9732 divided by 1. Well, that's just 0.9732. So we have to get the inverse sine of this thing here. So you see we get 76.7 degrees, just like we had here. Well, we don't have to actually work that out, because 0.9732 is this value here. So we multiply a half by 5 by 7.5 by 0.9732, and to 2 decimal places we get 18.25.